Alright, this video is 12.3 conditional probability. So today we're going to be talking more about probability. First we're going to start with the definition of what conditional probability is. So conditional probability is the probability of an event, called the event A. It's a probability that event A will occur given that another event, event B, has already occurred. Okay. So let's look a little bit more about what that means. First, some notation. If I see this, the P out front means I want the probability of these events happening. This is two events, event A and event B. So right now we don't know what those events are, but as we look forward, we will have an idea of what those events are. So we read this as, what is the probability that event A will occur given that event B has already occurred? Okay, so this one right here, whoops. So the first one right here is the one that we want, or that hasn't occurred yet, but we want that probability. And the second one, so the one that comes after this bar, this is the one that has already occurred. So for example, I might have a bag of candy, and in the bag of candy I may have Skittles and M&Ms. Okay, so Skittles have different colors. I may have red. So let's just say I have 3 red Skittles in the bag. I have 5 blue Skittles, and I have 2 yellow ones. Okay. And then I also have some M&Ms. Say I have 4 red M&Ms, 5 brown M&Ms, and I have 6 yellow M&Ms. Okay, if this is the contents of the bag, let's say your friend has the bag and they draw out a piece of candy at random and they tell you that this piece of candy is red. So they don't tell you what type of candy it is, they just tell you it's red. Okay, so the event that has occurred here would be, so event B would be that the candy is red. Okay, so that's all we know. We want to know what is the probability, let's call event A being the type of candy, whether it's M&M or Skittle. Okay, so let's actually specify. Let's say event A is type of candy being an M&M. Okay, so what is the probability of event A given that event B has already happened? So we already know that the candy is red. So how many possible outcomes are there that are red? So if I look up here, I have 4 red M&Ms and 3 red Skittles. So if I already know it's red, I know it's not these 5 blue Skittles, it's not these 2 yellow Skittles, it's not these 5 brown ones, it's not these 6 yellow ones. So I know it has to be out of these 7 ones that are actually red. So my bottom is not going to be the total number of candy in the bag anymore. It's just going to be the total number of candy that fit whatever event B, the one that has already occurred, is. So that would be 7 total possible outcomes. And then event A being the type of candy being an M&M. So what's the probability now that it is an M&M given that it's red? Well, there are 4 out of the 7 that are M&Ms. So the probability that it is an M&M given that the candy is red would be 4 out of 7. Okay, and of course we're going to change that to a percentage by doing 4 divided by 7 in your calculator, which gives me 0.5714, and then I'm going to move the decimal over twice to get 57.1%. Okay. Let's do a couple more things. So here I have my playing cards. Remember there's 4 suits, 2 of each color. They go ace through 10, and then they have jack, queen, and king. The jack, king, and queen are called face cards. Okay. So what if I wanted to know the probability that the card that I draw is a diamond, say, given that the card is red? So again, say your friend grabbed a deck of cards and shuffled it. They draw out a card and they tell you the card is red. Okay, then what would the probability be that that card is a diamond? So if I already know that the card is red, that takes out of the running all of the black ones, right? So those cards are no longer in my sample space because I already know that the card is red. So because half of the cards are red, there are 52 in a deck. There's going to be 26 possibilities now. Okay, the card is red, I already know. So now how many of those 26 cards that it could be, because it's red, are diamonds? And that would be 13, because there are 13 diamonds. So the probability that it is a diamond given that it's red would be 50%. All right, so let's try another one. Let's actually clear this. All right, so what if we wanted to find the probability that the card is, sorry, one second. All right, so let's find the probability that the card is, let's say, a face card, given that it is a black card. Okay, so how many total possibilities do I now have? If I know the card is black, how many possibilities do I have? That would be getting rid of all of these red cards. I know it can't be any of these. I know it can't be a diamond or a heart. So I'm going to take those out of the running. So the total number of possibilities, if I already know it's black, is again 26, because that's half of the cards. Now, what's the probability that it's going to be a face card, given that it's black? So if I look at the black face cards, there are 6 black face cards. So the probability that if I know it's black, it's going to be a face card would be 6 out of 26. Okay, so if I just change that really quickly to a percentage, it would be 23.1%. Okay, that was a funky looking percent. Okay, let's try another one. Let's say we want to know the probability that the card is a 10, given that it is, sorry. Okay, what's the probability that the card is a 10, given that it is in the heart suit? Okay, so if I already know that the card is a heart, then I know that there are 13 possibilities because there's only 13 hearts. The probability that it would be a 10, given that it's a heart, would just be the 1 out of 13, because there's only one heart that is a 10. Okay, so 1 out of 13 is 7.7%. All right, let's try something else. Here we go. If I can get my slide to advance. All right, so let's say our sample space is the numbers between 10 and 20. So the numbers between 10 and 20 means my sample space would be 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Nope, it wouldn't be 20 because 20 is not between them. So it would just go to 19. Okay, so there's my sample space. It's helpful to kind of write it out. Even if it gets a little bit big, you don't have to necessarily write down every number, but you really need to think about what numbers are included and what numbers are not included. So because it says between 10 and 20, that means we don't want actually 10 and 20 itself. We just want the ones between them. So we're going to look at this. What is the probability that the number is prime? So this one is not a conditional probability. This is just the probability that it's prime. So remember, a prime number is a number that is only divisible by 1 and itself. So like the number 2 is prime because the only two numbers that multiply to 2 are 1 and 2. But 4 is not prime because I could do 1 and 4, or I could do 2 and 2. If there's any other combination besides 1 in itself that could multiply to it, then it's not a prime number. So the prime numbers here between 11, or sorry, between 10 and 20 are these numbers. The prime ones are 11, 13, and 17. Oh, and 19. So we have 4 prime numbers out of 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4 out of 9 prime numbers. So quickly turn that into a percentage, would be 44.4%. Okay, what's the probability that the number is prime given that it's odd? So now we're not looking at all the numbers anymore, we're just looking at the odd ones. So there'd be 1, 2, 3, 4, 5 of the numbers are odd. So the only or the total possible outcomes are 5 if we already know it's odd. What's the probability it's prime given that it's odd? Well, it looks like 4 of those are prime, so that would be 80%. What's the probability that the number is greater than 5 given that it's even? So if we're given that it's even, we have 4 numbers here, 4 total numbers. How many of those 4 even numbers are greater than 5? All of them. So that would be 4 out of 4, which is 100%. Okay. What's the probability that the numbers are between 15 and 20 given that they're odd? So again, the total number of odd numbers was 5. How many of those odd numbers are between 15 and 20? So 15 and 20, there would only be 2. So remember, it says between 15 and 20. That doesn't include 15 or 20, but 20 is already not here. So it would just be 17 and 19. So that would be 40%. All right. A bag contains 6 red, 2 green, and 5 blue marbles. Find the following probabilities. So what is the probability that the marble I draw would be red? So there are 6 red out of, looks like 13 marbles. If I add 6 plus 2 plus 5, I get 13. So 6 out of 13 would be the probability of just reaching in and grabbing a red marble. So again, not a conditional probability, but 46.2%. Okay, now what is the probability that the marble is red given that it's not blue? So someone pulls it out, they're like, all I'm going to tell you is that it's not blue. So how many options are there available that are not blue out of the 13? There are 6 red and 2 green, so there would be 8 marbles that are not blue. So that'd be our total possible number of outcomes, given that it's not blue. And then of those 8, how many are red? So that'd be 6. So 6 out of 8. 75%. What's the probability that the marble is green given that it's red? Okay, so if we're given that it's red, there's 6 possible outcomes because there's 6 red marbles. But what's the probability it's green if we already know it's red? Well, that would be 0. So that would be 0%. All right, so let's investigate a two-way table. So using a two-way table here, if we wanted to know, for example, the probability that the person that we pick is a boy, given that they preferred baked potatoes. Okay, so we know that they liked baked potatoes, not mashed. So we don't need to look at that column anymore, right? So we're just looking at this one column for baked. So the total possible outcomes, if we already know they like baked, would be 121 because 121 people preferred baked. How many of those 121 are boys? 58. So the probability that they are a boy, given that they preferred baked, was 58 out of 121, which is 47.9%. Okay. So basically, if we're looking at a two-way table, we're going to take whatever comes second here, and that's going to be the column or a row that I look at. I'm not going to look at anything else because if I'm already given a piece of information, it takes some of that other information away. So what's the probability that a person prefers mashed potatoes given that they're a boy? So if you already know they're a boy, that takes this one out of the running. It takes all these girls out of the running, right? We'll just be looking here. So if we know they're a boy, then we know we have 100 possible outcomes. How many of those boys prefer mashed potatoes? 42. So 42%. Okay. What's the probability that they're a boy given that they prefer mashed potatoes? Right? It looks similar. We're using the same two data things, but it's a different order, so it's going to be a different answer. Because now we know that they prefer mashed potatoes, but we don't know whether or not they're a boy or girl yet. So what is the probability that they are a boy given that they prefer mashed potatoes? So now in my chart, I am not crossing out all the girls, I'm crossing out the baked potato because I know that it's a mashed potato. So this column would go away. This is the column I'm looking at because I know they're mashed. So there's going to be 79 total possible outcomes. How many of those 79 are boys? 42. So 42 out of 79 is 53%. All right, guys. Good luck with this today. I hope that you are staying caught up. We will be just finishing Unit 12. We will probably test on it on the 20th of May, and then we will be done. We'll just be using the rest of the time we have to the end of the trimester to get caught up. So try to stay caught up. You'll be done earlier. And if you have any questions, please contact me. Have a great day.